And we're live.
Awesome.
Hello, folks.
Hello, hello.
Hey there.
Hello, everyone. How's it going? So let's see.
Do we have our usual trolls in the chat already?
Let me check. Does anyone already asked for the clusters 24-hour stream?
No mention of 24-hour cluster. Yes, there's nobody there yet.
Hey.
Hello.
Hey.
Great to meet you.
Hi.
Hi. Nice to meet you.
We just went live.
Oh, sweet.
Just waiting a second.
Can we see like the chat from Riverside, or we have to open like YouTube?
That is a good question.
That is indeed. Okay. Let's see if someone says that we are live. I think that we are indeed. Yes, we are.
Yes, there we go.
Okay, I see now people writing in the chat. Okay, so we are definitely live.
I see.
Yes. So hello, everyone. How's it been going? Did everyone broke something into production last week?
Of course.
That's always fun. Of course, yeah. I know. I mean, the next
I
unit of
know I
measure.
did.
Oh yeah. I mean, people measuring number of PRs, number of commits, that does not make any sense. We should measure in number of times you broke something in production. That's the actual metric for
You guys
attendance
have stuff
programmer,
in
I would say.
production? I thought you were not supposed to. Just keep my apps on my computer.
Well, the way of never having a problem in production is never shipping.
Exactly.
Exactly.
If you don't write software, there's nothing that can go wrong.
Yeah. Best way to solve a problem, not having the problem itself. Okay,
Yes,
so
shall we start?
Yeah, I think so.
First of all, welcome to Nathan and Igor.
Thank you.
I don't know if you want to do a very quick introduction of yourself, or if we should jump straight into the Rivet SDK. I'm personally very curious to see how it all works. So yeah,
for sure.
Go ahead.
I'm Nathan. I'm the founder of Rivet. We're building infrastructure for long-running stateful workloads. And we've been working with Igor here, who built our awesome Effect SDK for Rivet recently. I'll let you take from here on that.
Hey guys, so I'm Igor. I've been helping Rivet to build their Effect SDK. Otherwise, from the side of that, I'm also working on LiveStore as a contributor, which also use Effect.
We ended up infecting your life, I see.
For sure.
Hope in a good way. Okay, so first of all, I would ask what even Rivet is. You know, like from why should one adopt Rivet, and what it gives that something else maybe won't give, and what are the overall use cases for what Rivet is, so the audience can start to understand what Rivet could be useful for, what are the projects that may adopt Rivet or may be interested in adopt Rivet in order to improve their software.
For sure. Yeah, there's been this interesting type of workload that's been getting really popular in the past kind of 2 years. We call it stateful workloads. And so Rivet is an open source alternative to durable objects. And so what that means is it lets you have long-running processes in memory. And one of the most common use cases, being 2026, is agents. There's a lot of use cases where you need some sort of agent or workflow, and you need it to run for a very long time, and you need to be able to store context in memory, do real time, do multiplayer. And so it makes that really easy. It gives you, on wake, on sleep, and networking, so you can kind of treat each one of your little actors as like a HTTP server. You'll be seeing the word actor a lot throughout this, because that's the core of Rivet's infrastructure and terminology. I think Effect people are also pretty much already familiar with the concept, because that's kind of the core of what you guys are doing, which is why I think it's cool to see everything working together now. Because a lot of the concepts kind of bridge really well, where we provide a lot of the infrastructure to run these things. Like, we provide a per actor durable SQLite. We prefer like a networking layer. So each actor has its own network addressable HTTP server. And then Effect provides a lot of the stateful, the background tasks and the cleaning up of actors, stuff like that. A lot of the problems that you see in production when you're not using Effect, running into actors and stuff like that. Use cases, pretty 2026, a lot of agents, obviously. We have a lot of real-time use cases too, because we're really good at like socket servers, kind of like a modern socket IO, if you want to think about it that way. We actually this entire product came out of gaming a couple years ago, where we were doing this before the whole AI thing took off, and people started looking at what we're doing. It's like, oh, that's actually something that we need outside of gaming. And so here we are.
I had a similar aha moment because my background history with actor systems is that I've loved Erlang and the obviously OTP messaging system and the BeamDM and so on and so forth back in the day. And then I went to do a lot of finance work, and we had highly available infrastructure systems and so on and so forth. So I went for, at the time, Akka in the JVM. At that point, AI was not a thing, like not even in the remote. Like, it was impossible to predict AI being a thing within the next 20 years from when the actor model was first brought forward. And it's so interesting that those primitives, very similar to Effect in a different sense, that were built for a different era to optimize for human problems. Because creating a highly concurrent system without actors is possible. Creating a highly production-grade system without Effect is possible, but it's hard. And we've built libraries and frameworks for humans to do that well. And it turns out the AIs exactly need what was old. Like 30 years old plus models are becoming interesting again, which is fantastic to see.
I didn't know your history with actors went that far back, but it makes sense, everything considering. But I think there's also like a whole other side to it that I could go on for a long time about. It's just like how agents and stuff is breaking infrastructure in 2026, and how everyone is just like crippling under load. I mean, look at GitHub as the most obvious example, but it's like you expose an API endpoint, it's going to basically get like a denial of service attack by every one of your users now, because they're just abusing your API. And so I think there's an interesting approach of also the more you isolate, the safer that your API is, because your users are like basically DDoSing you without even realizing it. And so you kind of need to be able to treat every user as like a bad actor in a sense. And that's also kind of something that it does really well.
Makes a lot of sense.
It is also like a model that I think people, like, as Mike said, resonate more with, because again, speaking the actor system is like kind of watching the reality, having like different person that have these different like purposes, communicate with each other. So it's also like easier to reason about, because it models thing around something that we are used to do every day. We speak with people every day, we send messages via voice, via text, or whatever. We eventually receive messages, we acknowledge that we have received them, and things like that. And so it's really funny also how something that was initially built like for gaming, it's becoming now like a standard de facto needed in order to build reliable software. It's kind of that pattern that
was primarily invented first around telecommunication networks, which is a very highly concurrent system, and obviously you have messages shared. You have bidirectional channels created between point A and point B, and you need isolation, coordination, and so on and so forth. That's why Ericsson first sponsored the work on Erlang and the Beam virtual machine. And yes, that's very similar to how humans communicate. For sure, we don't use shared memory. We don't have a shared brain between the four of us. It
The
might have
collective
been a
memory.
better, a more efficient way of communication, but apparently evolution ended
The
up
collective
preferring
brain.
individual brains that communicates via messages, and that's why I like actors so much, and why, for example, the effect cluster, which is our own interpretation of distributed computing, is also built on top of an actor model with different traits from Rivet. But I think we had a conversation a while ago on Twitter with Nathan about the trade-offs of one versus the other, what we wanted to support, and so on and so forth. But yeah, it's all very, very interesting and very relevant. And I would add another point to how agents are changing infrastructure requirements. If you think about response times, before agents, the usual API response time was in the order of milliseconds. Now with agentic behavior, API response times goes from milliseconds up to multiple minutes when you have sessions open and so on and so forth. So that fundamentally changes the primitive required to even model the situation. Serverless is almost always no longer an option. You need a more stateful model. You need more durable model, which I think Rivet is addressing.
I feel like there's a good Star Trek analogy there, and the humans versus like the Borg of like individual memory versus C++ memory.
Yes, we could segfault at any point in time. Good. Shall we see some code?
Yeah.
All right. I can jump in and sharing my screen. Let's see if that will work. All right.
There we go.
Mode, of course, it's more readable. It's a controversial opinion, but I do like it. So the way I was thinking about...
Can you zoom a little bit?
Wait, why my shortcut is not working? I have to do this manually. Hey, come back.
That's because of light mode.
Wait, it's not doing it. Well, that's design mode. That's not what I want. And I think there's a presentation made, so maybe that will work. Let's see. Well, that's way bigger.
Okay, I think that works.
Okay, perfect. So yeah, I was thinking like demoing this app first, which is a example app that we have like in the repository that is for a chatting app pretty much. Although it's focused more like on the backend, there is like a front-end client, but there's no like a whole web app, just a HTTP client that use the SDK. And so please feel free to interrupt me at any time if anything doesn't make sense. But otherwise, I'll just keep going. And so this app here, you can see that it has two actors, one for the chat room and one for a moderator. And something that you can right away see is that each actor is divided into two files. The reason for that is that I wanted to separate the actor definition and the actor implementation. And I wanted them to be in separate files so that we would be able to import that on the browser, on the client, without also accidentally like importing like implementation details from the server. Quote is only for the server. And so if we first look at how we consume them, we have this file here, which is a file that would be like running on the browser, which is just a small effect program that we first initialize the clients. So we get the clients from chatroom the client, and you quickly see that the API from this has a lot of similarities from effect cluster. For anyone who's like familiar, like there's the effect cluster, there's like the entities, and that took a lot of inspiration from it because my goal was to pretty much build a SDK for a Rivet that was the most effect idiomatic, while at the same time trying to be within the meta model of Rivet. So there are some differences that you'll see later. There was also like another constraint, which was that we wanted to the SDK to wrap the existing Rivet TypeScript SDK. So it's built on top of it, such that it can reuse anything that's already built on the TypeScript SDK. And so due to that, like the implementation is also, like behind the scene, it's pretty different. But on the API level, I look at like other also actor model-like APIs, but the one from Cluster I thought was the most elegant one. So thank you first for anyone who has designed that effect, because it was very useful to help there.
Well, a quick question.
Yeah.
Obviously, I don't have a lot of context on the internals of Rivet.
Mm-hmm.
I was curious if you evaluated an integration path where instead of building on top of the existing SDK, you'd have Rivet as the runtime for an effect cluster. I'm not sure if it's even possible. I was just curious if you investigated the direction at all.
I investigated, and from what I found, so that was right at the beginning that I did. From what I found, it was not like possible, although I could be wrong on that. But I think the main constraint is that like the Rivet, even like the Rivet TypeScript SDK, it has like an engine which is built on the with Rust. And Nathan, correct me if I said anything wrong. And that agent's like it's like runs with the SDK on the server, and on the client, I'm not sure if there's also like some like WASM code, or if it communicates direct with the backend. But at least on the backend, like the TypeScript SDK is pretty much a thin layer on top also of that Rust layer. Is that right, Nathan?
Yeah, that's correct. The client is just a lightweight TypeScript, which could probably be completely swapped to Effect at some point. We're just trying to get like a V1 out because people have been clamoring for Effect support. I'd be curious to explore cluster support more. We're like Effect has been a long story for us where we shipped like a lazy Effect wrapper. People are like, no, that's not good. It's like, okay, let's bring in someone who's like really good at Effect and put Niagara for this, and then we can look at what this looks like from here, because I'd be curious to see how far we can take it.
But yeah, pretty much like all the network request goes through that Rust engine. And so the SDK communicates with that Rust engine, and so we would need, I guess, to host that. Yeah, I'm not sure if it would be possible like to bridge that, but maybe that's something you have to explore.
Yeah, the reason I'm asking was like in Effect cluster, every piece is kind of modular. So you don't technically need to run our default implementation. And given that Rivet has the concept of actor/entity messaging and so on and so forth, I was wondering if the primitives map, there's a good intersection enough for the primitives so that if you have a software that targets Effect cluster, you can just deploy it on Rivet. And that's it. But that's just my curiosity. And
yeah, I think there's also like the deployment story there for like Rivet. Like often you are the one hosting the code for like Rivet. Like you can even host like on Vercel functions. So that I'm not anymore sure. Nathan probably could say more about this. Like it's not that you host the whole actors like in the Rivet infrastructure. Rivet is more like a layer infrastructure.
Yeah,
And
yeah. So
go on.
we have like the Rivet engine, or like the Rivet Cloud if you're using the managed version, and that's what handles like the SQLite persistence for each actor, and then it handles like the network, like the addressable actors, where each one has its own HTTP server, and then your code can either be on our cloud or it can bring your own cloud, including serverless, and that's where each actor runs. I don't know it's been a long. I think I looked at it like probably a year ago now at Effect Cluster to see like how that could be bridged. It's been too long, so I can't really say anything with confidence yet. I'd have to. I'll jump in your DMs later and shoot some questions over, and just out of curiosity.
Yeah, we could explore maybe at the end if you have time, like to see how that could work. Yeah, my memory is also a bit fuzzy there. So continuing here, we have this effect program where we have the a client that we get. So that would be for the chat room actor, and we get it by a key that we pass. And then we can see here that we can, using that client handler, you can call some specific actions. So that would be like equivalent to RPC on Effect Cluster. And here they call like action, and they're a bit more limited on what they do. And so they are more fit within like the existing Rivet mental model. And so then you can also, something that is like interesting is that the errors are kept end to end, and that's really thanks to effect here. And so you can see that this here room send message, you can see that it can error with like ban words error, which is an error defined into the code that we see later, and also Rivet error. And Rivet error, if we look into its file, it's like a error that has many different causes that map like to internal errors from the Rivet SDK. And so you can see here, actor not found, actor stopping, actor restarting. These are all different like causes within that higher level error. And so now with Effect V4, this is like a new thing. You can do catch cause, and then we should be able to see all the type of error here.
Catch reason maybe?
Oh yeah, catch reason, sorry. And then we can see, wait, that's the wrong error. There you go. Then you can see like all the different reasons of how like an error can occur. And then some of them you might want to do. And if any like errors, then add in the future, but the SDK is not yet updated, that goes to like Rivet error with the reason of unknown error. So that's a pattern that you see also used on the AI, Effect AI like library. So I got inspired by that there. And then, yeah, we can see we send a message, and then we, let me just revert this. Then we send another one, which like contains spam. And so that will create this error here, bandwidth error that we'll see later. And then at the end, we just get history. And so I'm gonna leave it to later for me to run this. And now I'm just like gonna move into actually the server. And so first I'm gonna go into the entry point where you can see here, the first thing that we have is to put together like our layers. So construct like our layer graph. And so first you take all the different actor implementation layers. So we have here chat room and moderator live. If one of those layers use any custom defined service, so we have here room policy, we provide it to it. And then we also provide a client here because like an actor can communicate with another actor. And so we have to provide also the client for that actor. So in this case, it's moderate chat room communicates with moderator live. So he also needs a client layer. And then here we can see that we have a pattern that's similar to like how HTTP router and HTTP server works on the Effect library. you have this registry.layer, which is responsible for collecting all the actors. So all actors register with that registry. And then we have registry.serve, which will just start a server, HTTP server, on your Node.js process. And that server is actually being run by the Rivet engine binary in the background. And layer launch here will then help us keep that alive. And we also have this to tear down on SIGINT and SIGTERM. And so that's similar as well to the APIs that we have on the Effect library. And there is also another one here that is for when you're within serverless environments. And if we now go into one of the actors, so the most interesting one is this one, the chat room. First, we have this file where I say we're redefining the API. So we define custom errors, we define actions. Similar to our RPCs, those have a payload, success result, and also an error that you define through effect schemas. Then at the end of it, you pass all those actions to the actor definition that you're creating. And then this actor definition can be important on the client, as we saw before here, to get a client. And it can also be used to actually do the implementation. And so in one of the previous office hour, we went a bit into this implementation. So there was some feedback that was suggested from this, which I'll address here. But first, let me just go walk through it again. So you can see here we have a custom service that I've defined with its implementation room policy live, and we are going to use that one within the actor implementation. And so to define the implementation, you have this two-layer method that you call on the chat room definition, and that accepts an effect which will be run every time that the actor wakes up. So when an actor is not used, it goes to sleep, and then when it gets used again, it wakes up. And that effect here is executed every time that happens. And there is a scope associated with it, meaning that every time the actor sleeps, it then runs all the finalizers. And so we can see here there's a finalizer for logging that this room is sleeping. And from the get-go here at the top, you can see that we are able to yield some services. One is the address of the actor, which include the name, the actor ID, and the key. Another one here is our custom service that we have defined here. And so this then needs to be provided with a layer. And it can also, at test time, we can provide something that's beautiful for testing. And we can also yield a client from another actor, so that's the moderator client. And the thing that is the most interesting is this state here parameter. So this is the wake options object, and it includes multiple things that you can use within your implementation. So at the moment, it only has the state, which is implemented with Effect Idiomatic API. But in the future, we'll allow for other APIs, such as connections, or I think there was another one, the queue as well. So those are other things that can be available here. And this raw Rivet kit context pretty much is an escape hash that you can use. In the meantime, those APIs are not yet implemented in the Effect world. And so this state one here is pretty much a value that allows you to persist state and get that state. So that state is persisted across different wake-sleep cycles. And it is type safe, type constrained, because we at the end here are able to define a schema for that state and also provide an issue value. And so here there's one feedback that was suggested, which does make a lot of sense, which is, would it make more sense to have this first into the API? First we define the schema, and then we get then this function here, this effect here. And that's what I had at first. But the issue the reason why I put this like as a second parameter, it's because there can be like Rivet actors that don't have any option. So this is like a optional parameter that, like for instance, like an actor that doesn't have any state. And so that's why this is put like as a second parameter. Though it might be arguable, like maybe this is so rare that happens that it might be better to move this as a first parameter. But yeah, small tangent there. And then we can see that we can consume this state value very similarly to how we consume a subscription ref. We can set, update, modify, and more importantly, we can access state.changes, which is a stream over every committed state change for this actor. And this doesn't use a subscription ref in the behind the scenes because it communicates actually with the underlying Rivet TypeScript SDK, where we have like some hooks that we can use to get the changes. And so if for whatever reason, like the state is changed from like a different place than from the effect SDK, the changes will still come through here in the stream.
If I can jump in, we also have a way for like in our debugging API to actually modify actors on the fly. So that's also why this comes in to help.
Yep.
Quick question. The lifetime of the actor is linked to every start and stop. So like whenever it hibernates, my finalizers will trigger, or is there anything more complex involved in tracking the state?
Every time it hibernates, that it sleeps, the finalizer will trigger, as you said.
Got it.
And then here you can see that you can leverage that to create like guards for like ensure member is part of like specific members of this chat room. And then here there's a preview of like the API for a feature API for like the queue, which is a concept that there is in Rivet. But I won't go into this yet because it's not yet implemented. And here at the end, pretty much you return all the implementation for each of your handlers. And so the one that's probably the most interesting here is the send message one. And so we can see that we use that guard that I just mentioned about, ensure member, that will use that room policy service that we declared above to make sure the user is part of that room. And if the user is not in the room, then it will return that error. And so we're able to leverage those things here to then get that error to the user at the end. And here we can also see that we are able to get like a specific moderator. So we're getting the moderator for our chat room. And then the moderator will review the message. And if the message contains like ban words, then we will fail this action with the ban words error, and that can be handled like on the browser. And here we can also see that we can still like use other APIs using like the escape hatch. So there is a DB API which uses SQLite, and so that uses here through like the escape hatch that we have here. And we're also able like to broadcast messages. That's also one of like the APIs from the escape hatch that's not yet modelized on the Effect SDK.
And quick question: where is the SQLite storage running? Is it just a plain local file system? Does it go in the Rivet server?
So that Nathan, you will be able to answer.
Yeah, so that's part of the reason that our core engine is written in Rust is because we have a virtual file system for SQLite that gets persisted to the Rivet engine side. And so when you do any SQLite query, there's like it's almost like Neon for SQLite is what I like how I'd model it is like you can boot a SQLite instance on your actor instantly and then start streaming in data as you go. and we handle the whole persistence layer for you. Yeah.
That's cool.
So I could imagine in the future, for example, wrapping that RivetKit context.db to get, for example, a plain like Effect SQLite client, so that in the future could be even effectified even more.
Exactly.
I had a question about we see that here that we have defined basically the handlers for each of the protocol messages that this actor can basically handle. I'm curious, what's the story for the concurrency of the execution of the handlers for the Rivet engine? For example, I would imagine that I may have like two handlers attempting to write to the state. Is there somewhere to configure Rivet to say, for example, this handler can be run concurrently, this is only one at a time, is it always one at a time? Just to know which is like the story for the concurrency in here.
Not yet. The way that we
okay.
the way that we like to recommend doing this is kind of more like our traditional handler. We have something called a run handler where you can actually just like get a function call, and which is also great for effect. And then you can consume from like events, like our queue, for example, and then you can do that in just a for loop and structure concurrency however you want. Yeah.
So actors currently are processing messages sequentially.
Sequentially, okay.
Yeah, like the actions are actually in parallel. Like, you know, sequentially in like the JavaScript runtime sense, but
they're not like they're not like they are concurrent, right?
Yeah. Like it's basically an HTTP call. It's like for each action, and then if you want to serialize it, you can either add your own thing or you can use like our run handler, which then you could just do like a while loop of like while give me next event, handle it, and then you just create back pressure on that next event queue.
All right. So now,
so just to understand that there is no ordering guarantee. If I send two messages to the same actor, the actor can receive them in the opposite order.
Oh, I see. Yeah. So that is there. That is handled by like the client, and so everything is serialized over the WebSocket, and then the way you send it from one client is the same order you get it on the other end on the actor.
Okay, so for the same client, I get an ordering guarantee.
Okay. Okay, so if two different clients, for example, try to communicate with the same actor, there isn't ordering guarantee, but there is ordering guarantee per client, just to explain that. Okay.
All right. I'm quickly just going to show the moderator, but it's pretty simple. It's just that call that we had, a moderator.review, and just check if one of the words is part of the banned words. It also could be like a service here, a custom service. And then now I'll go just into the telemetry aspect of this, which also needed like to integrate in a way that made sense with the Rivet SDK. So the underlying Rivet TypeScript SDK allows you to pass a Pinot logger configuration. So there is pretty much like a logging base logger option where you pass this Pinot object here, and then you pass this option for Pinot. And so I needed a way where if someone would log something here in the SDK, so here just like effect log here, it would like show in the same way than if something was logged within the TypeScript SDK. So that will be consistent. And the way that I modelize this is that first, by default, there is like a layer that is like a logger layer that is configured when you don't pass any layer, when the user don't pass any layer. But then the user can also pass like a custom layer configuration, passing like a Pinot configuration using this Rivet logger dot layer from Pinot. And then through that, you're able to provide that as a layer, and then that will configure both the Effect SDK and the underlying Rivet TypeScript SDK to use that same Pinot configuration. And so now I think it would be a good time for me to just demo running this. So let me just switch the screen that I'm sharing, and let's go into the terminal. All right. This one, I'm also gonna make it bigger.
Yeah, I think a couple of bumps more.
Is that good?
A little bit more if possible, I think, just to match what we had before.
All right. Okay. So first I'm gonna run the server.
The stream might be frozen. I don't know if that's just me.
Yeah.
Say what?
The stream might be frozen. Maybe that's just me.
Oh.
Yeah, it's frozen for me as well. Yeah.
Okay, let me.
Sorry, that's why I asked to bump more.
He's got like crazy font size on his screen.
On his end, it was like one character per window.
Right. Do you see anything now?
Yeah. Okay. Yes. Okay. Thank you.
Okay, so now I'm just gonna start the server here, and we're gonna see that the RivetKit server is running. We get right away a log here, and that's configured with the log that I pass here. You can see I said like pretty, and that's why we have like the colorful log here. And then I'm gonna run the client, and you see pretty much every step that we had on that client file that we saw first. Ali joined, Ali sent a message. We can see the...
Is it frozen again?
Okay, yeah.
Oh. Wait, let me try to share the whole screen. Maybe I'm not sure if it's my internet. Is my audio okay? Or it's just Okay, maybe if I share everything, it will work better. Okay.
Okay.
I see something?
Yes.
Yep.
All right. So I run here the client, and you can see all the messages, all the logs for all interactions that we had. You can see also the errors that we logged. So it rejected non-member message. Mallory is not a member of this room. And there's also the logs that are coming right from the TypeScript, the underlying TypeScript SDK. You can see that they use the same logging configuration. And yeah, and at the end, like we pretty much make the room sleep, and that's how the program ends. And we also have here an example of like you can use the raw client from Rivet, and it still works with if you only have like the backend that is built with the Effect SDK. So you can still interact with that raw client, and so you can do like an incremental migration if you're on Rivet TypeScript.
We also have a Rust SDK. Nice. Rust SDKs in other languages, so that's also kind of plays all well together.
Mm-hmm. And how do you handle, like, I guess type inference? In this case, it's TypeScript on both ends, so you might be able to derive it directly. I'm curious if your client is in Rust or other things, how you get the types to match up. But I guess this is
TypeScript SDK, you mean, or here?
No, I think Nathan mentioned that this could also be a Rust client.
Yeah, no, we haven't had like figured out automatic type generation yet, but
okay,
it's something people are asking for right now, and we're like, we'll figure it out. Time will tell. Have you done anything with that with Effect, like type bridging?
We are exploring, so we're building something internal where we do have Rust in the pipeline, and we need to do some type conversion between one side and the other. And we were kind of looping over different types of solutions. I don't think we have an answer yet, but it's something we were investigating. But that's the reason I asked. If you had something, I wanted to have a look at it offline.
Yeah, no. We on our like Rust API, we do a lot of generating JSON schema from our Rust types, and then we generate that back into, I can't remember if it's just type definitions or if we actually do Zod, but I'll be curious to see what you come up with, because I figure that'll be cleaner.
The issue with that is that the JSON schema is fairly lossy.
Yeah.
Like there's only a subset of things you can represent in JSON schema. So that's exactly what we did at the beginning, but we were not really satisfied. I feel like where we settled on was, okay, at some point we need to implement an actual generator of Rust code, but we haven't done that yet.
Yeah. Well, I'll keep an eye out. I'll be happy to try it out.
And yeah, there was one last thing that I forgot to demo that I think you guys will appreciate, because that's also thanks to Effect. But of course, we get distributed telemetry tracing. And so for that program that we ran before, you can see here that we have this OpenTelemetry trace where you can see all the spans from both on the server and on the client. So this is the client side span, then there is one on the server, and then we see for the other actor as on the client, and then the same other client but on the server. And you also get the errors that show there for like that specific span, the error there, and the events of the error. So that's all thanks to Effect telemetry that is embedded into it, which makes it very nice for someone that's not coming from Effect. Yeah.
That looks great.
Yeah.
And
that looks nice indeed.
Yeah, otherwise there's still a lot of stuff like that can be implemented. First, like just implementing the other APIs that have not yet been implemented with Effect. Then there is also one suggestion that was done in the previous call, which was to instead of having the state be accessed as a parameter, to be something that the user yields. And actually, I did a solution with that today, but I'm still not yet convinced. Fully convinced is like the best path. There's some stuff that in terms of ergonomics that I'm not yet sure. But the idea is pretty much instead of like having the state as a parameter, you would yield a custom state that the user defined previously. So yield the chat room state, and then this chat room state would then be provided as a layer higher up into the graph. But the issues there is like if the user just yield the chat room state, how can I get like good errors that it shows the user still has to yield? And from my experimentation, I've still didn't achieve that fully. But there is a working version, but it's just the ergonomics not yet really, really good.
Makes sense. Just a quick question around stability. Is this in beta currently? Are you seeking feedbacks? Is the API stable enough to ship this in a production server? Is this production? Igor was like, nope. No.
You know that by saying that tomorrow you will have something like 50 production users, right?
Yeah, our community does not listen to advice. I advise them multiple times not to use things, and they still use it.
Yeah, I'll let you share more there.
Oh yeah, I mean the Rust has been like it's post 2.0, so it's been post 1.0 for a long time now. So the core infrastructure, like my understanding is the effect is like it's going to be like API stability, like things are still prone to change, like we were talking about, and there's still parts of the API that we're trying to effectify cleanly, like the database stuff definitely has been on our mind and stuff like that. But yeah, the core infrastructure, the Rust, like it's in production with a lot of folks already. Both on our Rivet cloud and on-prem, we do a lot of on-prem deployments too. So
yeah, for the Effect SDK, there is a lot of tests if you look into it. I also had fun with using the type tests, which I didn't use before, like with Vite. You can now test the types, or maybe it already exists for a long time and I didn't know. So we have a lot of tests, but we haven't yet had enough like users for me to be able to say like it was confidently on production. Like it was released 2 weeks ago, and so just now I guess people are starting to use, and so yeah, I would call that more like, I don't know how officially you guys call, but like either alpha or beta. That's pretty much the first users try to use this now, except me and the other tests that we have.
And just to clarify, this is wrapping your current SDK. So if Rivet on the server side is stable, if you use Effect, you're not going to break anything, and you always have the choice of, okay, it's not stable enough for me, I can rewrite to plain TypeScript or Rust or whatever I like, and keep that.
Yeah, it's just wrapping there. I'm using directly the TypeScript SDK. It's got the same APIs you would use as the ones I'm using behind the scene. Everything that is like public. I'm not going through like behind the scenes and
not taking shortcuts with the server, basically.
Yeah, yeah.
And it exposes the raw context, which is like a raw object. And everything there is actually a very thin call into Rust. So there's actually not a lot of JavaScript going on between Effect and our Rust engine, at least on the actor side. The client side is all JavaScript, but on the server side, it's pretty thin between there. So
exactly,
it makes sense.
Yeah.
Yeah, and some other things that could be improved. Some ideas is that improving like how testing can be done. Like for instance, I wish like there was a way for the user when they're like testing an actor that they could swap the state primitive that we expose to the user. So like they could put their own maybe a subscription ref there, or something later for like the database. At the moment, like it is not like easily swappable on the test side with like the effect APIs. But I think that definitely would be something that would be really nice to have. And it could be through like that exchange that you guys proposed. So that's the thing that
I was about to ask if, in fact, what is the testing story for the test, even with the plain Rivet SDK? You probably mock either the behavior or the entity, or you run the entity in memory and you attempt to run that. How's the testing story for Rivet right now?
On the engine side, or sorry, on the Rivet side, like the core Rivet,
yeah.
We literally run the full like Rivet cluster, in memory for you. So like we're if you're doing integration tests, you can like test the full thing confidently. And then there's layers below that, but we put a lot of work into making sure it's portable and really lightweight to run anywhere.
So basically, the story is keeping the runtime as thin as possible, so you can run it basically portable, whatever. And the testing story is basically running that thin runtime in memory or whatever you are want to run that to test it with a real runtime.
Yeah, exactly. Yeah, we're a big, I think like you guys are a big fan of like libraries over SaaS, of like give everyone a TypeScript API, like let them do whatever, especially the agents, as opposed to like making everyone have to sign up for service or like use some black box, thing to run everything.
And for the effect SDK, pretty much I have a test layer that provides a lot of the necessary service, similar to Effect Cross Africa also has that, like a layer test, and I can and uses like the test engine pretty much.
That sounds nice.
There's a question in the YouTube chat. The user is asking, they mentioned the use case of long-running agents a few times. What are some concrete examples that people are using long-running agents for in real products?
Yeah,
I have some in my mind, but that's for you.
Yeah, I mean, I like the most basic version of a long-running agent is even inference request that lasts for a long time. But a lot of that gets more interesting when you start thinking about the context that needs to be held, whether it's like outgoing WebSockets. Like a really simple example is like holding WebSockets to OpenAPI, like OpenAI cuts your latency by a lot, and that's a very basic staple workload. And then there's things like loading user contacts or loading MCP servers, and that just starts building layers on top of the inference, where you want to keep these in memory instead of trying to do an inference request, shut everything down, and then start it up again. Especially with like GPT fast mode and these smaller models, it's much faster and cheaper to just like keep it in memory. Almost like a turbocharged Redis is how you can think about it. Redis with code attached to it, kind of one interpretation.
And also, I guess another very interesting use case of actor models in general, especially with hibernatable state, which is like durable objects in Cloudflare, Rivet, or any custom implementation that a user can think of. Like, for example, we are architecting a lot of workflows where, okay, what happens when an issue is created? We might want to run a model in an isolated state to investigate the issue without access to API keys and stuff like that. Maybe open a PR, maybe write a message in Slack, from a user feedback, run again from the same state, and so on and so forth. And there can be like a week or two from the moment the issue is open to the moment I check the issue and I have a reply. Then it might open up a PR, that might be a review in another 5 weeks. So long running, that doesn't necessarily mean it's always on. It means the process can spawn for a very long time with a lot of actions in it. And obviously implementing that without something like Rivet, something like Effect Cluster, something like temporal, restate, and other. They all different but they address similar solution spaces. You need to implement a lot of things your own, because you need to persist the state. You need to make sure that when you restart, you don't redo the old operations, and that there's always a lot of very complex and tricky to test behaviors that if they go wrong in a very bad way, the worst possible moment. And that's the reason implementing these things in library land, like we do for Effect Cluster, like Nathan and Igor and the Rivet team are doing for Rivet, and the other teams are doing a phenomenal job, because it's exceptionally complex domain to operate on. It's purely distributed systems where everything can go wrong, and your requests sometimes spawn weeks, not milliseconds. And if there's something that can go wrong in 5 milliseconds, be sure there is something that can go wrong in 5 weeks.
Yeah.
Like if you extend the lifetime, something will happen. That's kind of I don't know if I invented this law or not. It's just basic probability. Given enough time, an error will happen. Maybe it's Murphy's law. I don't know.
Yeah, there's so many people like not evident as well, like the complexity, like the for instance, when I was like working at Ingest, like something that was very challenging is how you deal with when you have a workflow, like a workload that has to be running like through like maybe months, and then the code changes, like the code executes the thing. That's something like that is, you don't think about it when you're first implementing your workflow, but then you have to be aware of that, because that same code will be executed later on, and it can have different behavior, and how you handle that can be tricky.
I think we could probably have another hour-long podcast on just that alone. I'm sure everyone here spent a lot of time thinking about that.
And that's actually the reason why I'm exceptionally against solutions that serialize the code itself, because it does not, the code itself. I've seen different solutions do that. AWS Step Functions, the most famous one, but also I don't want to name explicit products. I'm fine shitting on AWS. Everybody does that. I don't want to name other solutions in this. But the issue is your code needs to be updated. If the code runs for a long time, the probability of you wanting to update the code mid-turn is even higher. So you need to take care of that stuff properly. And there's various ways to do that. I'm sure Rivet has its own interpretation, but even I have the full freedom of defining what's happening inside an actor. I feel like you give enough flexibility for users to model their own versions of what they mean by some usual ways. It's like you don't change the message type, you add a different type of message that the actor can handle while keeping the old instances backward compatible. There's millions of ways, but yes, all of those are exceptionally tricky problems. And I agree, we could go on a podcast for 2 hours just on this topic.
That's also one of the reasons we adopted SQLite. Is like we took a long time before we were like, okay, we're going to go all in on this, is because it is a very standard way of how do you take data that is sitting on disk and keep it alive with migrations. And then there's a lot of tooling, and like you guys have great tooling. Drizzle is tooling for like creating a very user-friendly way of mapping over that too. So. The other last thing I would add on the long-running workflows is I think the real-time story is really great. I think a lot of people, when they're building agents, they start out where they just have like an inference endpoint, they do their inference and they get it back. And then you start realizing that users need to look at what agents are doing. And that is inherently a multiplayer problem. And doing that without sort of an actor model, it's possible, but you're now stacking on a bunch of other services and plugging in a bunch of other things that can all fail too. As opposed to with an actor, you can just kind of have an in-state process, and then you can have your agent running and connect a WebSocket to it and see what it's doing in real time, which is really cool.
There's a slightly confusing question from a user in the YouTube chat. The context they provided is that they are building 100% front-end geospatial platform to visualize and navigate UHD digital twins, and they have an internal actor implementation. They evaluated Rivet and ultimately decided to go with their own version. If I can interpret the reason, it's most likely because Rivet has a server dependency. So I feel like the question is more along the lines of, would it possible to run Rivet completely on the browser without running a server process? Would it even make sense to do that?
I mean, it's technically possible. I think our strengths really come into like running Rivet on the server, and that's kind of where Effect really plays nice. I think Effect does a great job on like the actor like patterns, especially on the front end. And then when you plug it into something like Rivet, you get a lot of the benefits of like or fault tolerance, like a lot of the networking benefits for the Rivet shaped actor model. So yeah, I mean, that's one of the reasons we really invested heavily in Effect, is like it kind of creates a really great story from front end to back end of this model that you have in mind.
Makes sense. Okay, the questions are getting more confusing.
Yeah. So maybe that's
anyway. Yeah, apologies to the user. We're just going to ignore the follow-up questions on that. It's like a thread developing with interlinked context. Good.
There is one about Effect RPC. Another question.
What about Effect RPC?
Is there an example of how to use RPC in React server components?
Okay, that's not for Rivet. We're gonna discuss Effect unrelated things to Rivet in the next office hours.
Yeah.
So if you have questions about Rivet and the Effect integration, please fire them off now. I'm just gonna ask one out of my mind. What are the next steps for you folks? Rivet in general, and how do you said before you had many questions around Effect usage with Rivet. Where would you like to see this going in the future, and if there's anything we can help you for the Effect integration and support around Effect and so on and so forth. Obviously, we're both open source solutions, so we love to support each other in any shape or form.
Yeah, for sure. I mean, on the Effect side specifically, like we're working towards getting that to 1.0, and like we have some exciting stuff coming up with SQLite too, where we rewrote our engine from scratch with a V2, and which enables things like forking, and like so you can start like doing preview namespaces, and then like basically fork your namespace kind of like Neon, where you have all your actors and you can test against it. And so that all kind of like pipes into the whole like Effect database stuff that we want to look into. Outside of that, it's a lot of agents, lots of integrations. Like some people look at us kind of as like an on-prem AI cloud, kind of like there's Vercel and Cloudflare, which are great platforms, but sometimes you really need to be on AWS, and that's where Rivet plugs in really well. And so we're putting a lot of work into integrating with basically everything under the sun right now. And kind of like, if you can do it on these platforms, like you can get a really good experience on-prem doing the same thing.
Yeah.
Makes a lot of sense. And Rivet is fully open source. So what license do you use?
Yeah, we have, there are a couple of commercial things, more so on like the kind of enterprise grade, like running things of like, if you're a big company and you need these specific things, we do have those as closed source like add-ons. But the core is completely open source. We are Apache too. We're big believers in permissive open source. This is something that like I'm always trying to build for, like, if I was trying to use this product and I'm not, literally the founder, what would I need to make that happen? And Apache 2 licensing is one of the biggest things, especially since like companies are companies, and God forbid something happens to Rivet, like you want to make sure that you're building on a really solid foundation, because when you're building on Rivet, like it becomes the core of a lot of companies that use it. It's kind of like an all or nothing type thing. Or use it for like an agent, and they start realizing, oh, it does this really cool real-time stuff, or I can do like I can replace Redis with like a more mature alternative in Redis with Rivet and this type of thing. So, yeah.
Yeah, we share similar philosophy. I also think Effect can only work with either MIT or Apache 2 type of licensing. I don't think anyone would adopt such fundamental solution if it was not truly open. And obviously I share the position of running a company where there's an open source project and having a lot of care to keep the open source truly open source. So
it's
good job for now. I wish you the best, and I hope to see Rivet succeeding in this very complex life of trying to model company and open source done right.
It's I mean, every I wish there was like a playbook for every single open source company, but it's one of those things where you need to figure it out, but also once you get users, it usually gets easier. Like front-end libraries are kind of tricky, but for anything that like involves a server and live systems, like companies doing these things generally need a support team, need like an SLA, need this type of thing. And there's also a bunch on the deployment side where it does make sense to like, okay, you can monetize people using this in production, like they want support. You can kind of justify that really easily in terms of pricing. But yeah, open source it's fun because you love what you do. It makes it possible to do what you do. You couldn't do it without it, but also like monetization is always an interesting story.
Yeah, and many people have the concept of an open source first company, and to me it makes no sense, because open source is literally giving stuff out for free. A company is giving stuff out for money. Like the two don't usually match so well, and there's only a subset of open source projects that actually allow for a company to be created around it. I feel like something as fundamental as Rivet is one of those cases. I hope Effect proves to be a similar story. But if we take something like Zod, it's an amazing library, has a lot of usage. There's no way of monetizing it.
Right.
There's literally zero avenues. So I'm always scared to adopt projects when there's a company behind it and it's unclear what the boundaries are, which is the reason I've asked. But I think Rivet is positioned in a space where this makes tons of sense, because you have people running their own infrastructure, they're going to need support, as you said. And
it's making open source healthy is like a whole different conversation that like
yes.
I don't think there's a good answer to
podcast.
But it's like well, we've got another 4 hours after this. We're good.
Meanwhile, we got a couple of questions. There is one asking how Rivet is compared to Dapr. Not sure if you know what Dapr is.
Dapr DPR, that one. I have not used it personally. I actually, I don't know enough about it to actually give you a straight comparison. I know that they have actors in it. I don't remember about language support. I will say that Rivet is very, very, how do I put it? I'll put it this way. It's like, if you're looking at Rivet, what we do really well is we give you the actor model, obviously, as we've discussed, with a specific attribute, it's technically called virtual actors, where your actors can wake up and go to sleep when not in use. And so that's kind of the idea of like, I have a user actor, I can communicate with the user actor, and it'll wake up when I talk to it, and it'll go to sleep when it's not in use. There are other actor like infrastructure components that are different, where like it's more of an ephemeral actor framework, or it's like a hybrid. And then the other thing on the Rivet side is we also provide a couple things like we provide you SQLite for your actors, which is like one of the core components of how do you take a system and run it forever, right? Like it's one thing to just have a JSON blob that you write somewhere. It's another thing to have like a system that you run for years and years and years. And like the observability story, I think is pretty good in Rivet, where we have tools very specifically built for the actor model, where you can actually go in and see what your actor is doing in real time. You can get a little REPL, like a shell into your actor to work with it. Stuff like that. Like it's a lot of nuanced things, but yeah, I don't know if I'd have to tell you the specifics, but hopefully that gives you a couple things you can look at of like where I think we really stand out.
And so we got another question from Joshi York asking, can you explain more about how Rivet is a better Redis? I'm not quite following how the actor model that's been discussed conceptually replaces a key-value store.
Yeah, I would not say Rivet is a better like cache if you're just doing reads and writes, but I think, and actually, I guess I'll go a bit in the backstory of how we got here. One of the reasons we actually developed Rivet in the first place is we were doing a lot of matchmaking in gaming, which is a real-time use case, and we were building this on Redis, and we were writing. It got to the point where anything you do more than a KV read write, you start working with data structures, and then you start trying to pair data with that data structures. And where Rivet shines is instead of just having the data structure like be string KB, it's actually better to have it be a piece of code, because that means that when you're doing high performance reads and writes, you're actually reading in memory, as opposed to with Redis, you're still going over the network for every single read and write. So in the example of our matchmaker, we used to have a bunch of lobby states in Redis, and then we would try and figure out how do you, we ran into 3 problems. One was data structures change. Redis doesn't play very nice with data structures changes because it's a cache. It's not meant for like live data. We ran into kind of consistency issues of like, how do you update your matchmaker state atomically? Like when you have a bunch of things reading and writing, Redis just does not play well with like transactions or anything like that. And then 3 is like when we actually tried to fix that by writing Lua scripts that ran on Redis, like our complexity just spiraled. It was awful. It was terrible. And then like it started getting slow because you're running Lua instead of, anyways. And Redis is like primarily a single instance thing unless you do Redis cluster, and then you're in for a world of hell. But I think that like if you're doing KV cache, Redis is great. If you're doing anything more complicated, I'd recommend seeing what it looks like when you pair your code and your memory together.
Okay, so just another question. We have Conan asking, Nathan, how would you draw parallels between Rivet and Cloudflare, Think, and Durable Objects?
Yeah. Yeah, I mean, Cloudflare is doing a lot of great stuff. I think that there's a lot of like parallels in where we're going. Like I put out a tweet the other day. It's like every time we learn about durable objects through our customers who are evaluating Rivet a lot of the time. And it's funny because we'll like have developed the same thing in parallel like months ago. So there's a lot of parallels there where we're kind of building in the same direction for very 2026 agentic real-time workloads that everyone is kind of seeing. Cloudflare's infrastructure is very baked to their network. So they have their edge network and their own workerd runtime, which is a very cool technology. I love it. But we're very focused on like open source, and we believe strongly in you should be able to run everything locally. You should be able to run on-prem, and not only run on-prem, but have a good like distributed computing story on-prem. And so the way that a lot of people use Rivet is they will take Rivet Cloud and deploy into Rivet Cloud because it's an easy experience. We have an edge network too, similar to Cloudflare. So you're not sacrificing your latency or anything like that. And then they can also deploy on-prem for their clients, or they can have like a very, a local development environment that mirrors that. In terms of APIs, there's a lot of parallels. Like we have a durable objects Rivet like migration 1-to-1 guide where you can look at every Cloudflare API, see what the equivalent Rivet process is. So durable objects, SQLite, you have your WebSockets. We have hibernating WebSockets, which means you can hold a WebSocket open to an actor while it goes to sleep to save resources. Project Think is like, I think out of scope. Project Think is their like custom harness built specifically for durable objects. I'm not going to talk too much about that because that's also another podcast. We also build a lot of open source components that are like have nothing to do with Rivet specifically, but kind of parallel a lot of the really cool info that Cloudflare is doing. So they're doing a lot of like dynamic code evaluations. We have a library called SecureExec, which is kind of built in parallel. It's one of those things that's like a really funny coincidence. SecureExec is like basically a sandboxed Node.js without sandboxing infrastructure. So you can import it as a library and get secure code execution. We also have a project called Agent OS, which is like a kind of a WebAssembly lightweight based virtual machine. And like we have a lot of visions in parallel with Project Think, where Project Think has I think they call it tiered compute. We call it sandbox mounting, where like most agents don't need a full like 2 gigs of RAM to do their work, especially if they're just doing like reads and writes or Git operations. And then if you need like a crazy like Rust compiler or something, you can opt into full sandbox. But that's way out of scope for this call, so I'm gonna leave it there.
I'll actually pick you up offline on the last point. I'm exploring something similar myself, so
yeah, let's chat. We're launching some stuff around that too, which very soon, which I'm excited to share.
That's really, really nice. Good.
Nice.
I don't see any other question. There's one that I can address quickly. Is Effect planning to have a managed Effect cluster service in the future similar to Rivet? There's a key difference here. Rivet runs their own server, which is a piece of infrastructure you either have to self-host or delegate to Rivet Cloud for a production-grade solution there. We don't have anything similar for Effect Cluster. So a managed service around Effect Cluster would be a general purpose deployment platform where you can host any piece of code. So that's the key difference, and why we're not just following the playbook of a managed Effect. I don't think, unfortunately, we are in the same position as Rivet, Temporal, and other folks that have a very clear plan of like, yeah, if we host these users, this is a pain point, we can solve this pain point via cloud thing. We have not introduced anything like that in Effect yet. So I'm not sure in the long term it might be, but in the short term we don't plan for that. At least very short term. Apologies, I addressed an Effect question, but I've seen in the chat, and the Rivet one where the queue was empty. Let's put it this way.
Okay, I don't see anyone else. Let me also check our office hours channel just in case someone has landed questions in there. No, we don't have one.
No, that's fine.
That's fine.
Good.
All right.
Well, I think we can call it a day.
Yeah. Thank you guys so much for hosting us. It's been a pleasure. Also, great to finally meet you guys, because I've seen you guys on Twitter and stuff like that, but I feel like that does not do it justice.
Thank you so much for joining us, and you obviously have an open invite anytime you want to share anything related to Effect and so on and so forth. You're always exceptionally welcome, and thank you for the open source work. For sure.
Thank you again for everything, and also thank you everyone who followed us.
Yeah. Thanks all.
Cheers, guys.
Thank you.